All right, I gave you individual feedback on your questions. I've already put out a video going through number 2, number 3, and number 5. But here is number 6 and number 4. Number 6. I'll show the answers and then I'll talk through how they wanted it scored. Scatterplot supports the newspaper report because the number of semesters, it shows a positive association between the two variables. So that's why it shows that. And that's the main thing that you needed to say. You needed to say that there was a positive association in the context of the problem. Slope, oh my goodness, I am still having people not right predicted. Do not say that for each semester it goes up by 1.1594. It is predicted or expected, or it goes up on average. Those are the phrasings that you want to use. Make sure if you're interpreting slope or if you're interpreting y-intercept, you are putting that in your interpretations. Part C, it gave you some new graphs and asked you about the association there. If it asks you to describe the relationship between the two, strength, direction, and form. So strength, there was a strong, direction, negative, form, linear association between the number of semesters and starting salaries. So strong, negative, linear association in the context of the problem. Then for part D, you needed to compare them. Business majors were the lowest at about 38,000. Physics majors next at about 48,000, and chemistry majors were the highest at around 55,000. Important note here, just stating what the three of them were was not enough here. You needed to also compare them. So you needed to say somewhere that, hey, this one was the lowest, this one was the middle, this one was the highest. Same thing when we go to talk about the 2015. There's going to be a question where it asks you to compare two distributions. If you just said what the two medians were, that's not comparing them. Comparing the median, this one is 10, the median, this one is 11, not enough. You need to say, the median, this one is higher or about the same or lower. Now we're comparing. Comparing is not just listing out what the things are. And then part E, the main thing, they're looking for you to say two main things here. Number one, that the newspaper report is partially right because of that positive association overall. But the second thing, which is the part most of you said, that it should be modified to say that within the majors, the longer amount of semesters have the lower starting salaries. So to say the place where in part the report is correct and in part where the report is not correct. Questions on number 6? Hopefully this felt a bit more doable than some of the other question 6s we've been looking at. Scatter plots tend to be a place where we at least know some of what we're doing. Yes? So for yours, let me read yours. So you're kind of, I would say you're kind of dancing around both ideas. You're saying like, as can be seen from the business majors, this is not true. Or you're saying like, you know, the report does have, it makes a general claim, and you should say like, that general claim is in some sense correct, but here's how it's not correct. And be specific about that. Sometime later I can show you what specifically what the guidelines looked like so that you can see exactly what they were looking for. So, moving on to number 4. On parts A and B, if you got the answer and showed your work, then you got the credit. Part C was asking you to use that probability you found in part A, that this probability is very low, that if the failure rate was 15%, the probability that we had all 30 go off successfully in a row is quite low. So that gives me an idea that we might be lower than 15%. That's basically like using a p-value and comparing it to an alpha level. But you didn't have to say that. You just had to say that that probability that they all fired successfully was quite low. For part B, the biggest thing is that given that there are no failures in the first 30 trials means that we don't need to factor that into our probability. Right? If the 31st occurs, the probability that the first failure occurs on the 31st trial is 0.15. If we already know that the first 30 fired successfully. Now, if it just asks what's the probability that the first failure occurs on the 31st, then you would have to do the 0.85 to the 30th times the 0.15. But since it said, given that the first 30 already fired successfully, then we can say that it's just 0.15. And then the 32nd means that the 31st has to be successful and the 32nd has to fail. So, and we multiply. And so we're looking for the 31st or the 32nd. So, or means we add those probabilities.